Hello and welcome. In this lecture, we're going to be trying to understand a little bit more about these vector structs and the mathematics that underpins them, so that by the end of this lecture, you will feel comfortable adding and subtracting vectors as well as multiplying them by floating point values. Let's dive in. So soon we're going to want to start setting our impulse in the correct rotated direction. But before we do that, we need to understand a little bit more about the mathematics that underlies vectors. Now, in this video, I'm going to be giving you a whistle-stop tour of vector mathematics, but if you want some more in-depth explanations, then we have a whole course on maths for game development, which I would highly recommend. Vectors are essentially a mathematical concept, and they're quite simple when you boil it down to what they actually mean. A vector is simply a direction in 3D space, and it is a size, or in mathematical parlance, a magnitude. Now, this is all fine, but when it actually comes to representing this on a computer programmatically, it's even simpler. It's essentially just three floating point numbers, an x, a y, and a z component. And that perfectly represents a three-dimensional vector. So let's have a little look at vectors in two-dimensional space, because here I've got a two-dimensional screen. It's easier for me to show you that. So imagine we have our x and y components, and we start off at the 0, 0 point being here in the top right for this example. And we want to position a character in this two-dimensional space. Well, we can have a position vector that points to the location of the character and has a length that takes you from the 0, 0 point all the way to the character's location. And this can be broken down into its component parts, so you can have an x part and a y part, just like you might expect, and how we were doing in our level in Unreal. Now what we can do is we can apply a movement vector to this position vector, so we can have another vector that has this direction and this magnitude or size, and we can actually add those two together to get us a new position like so. So this would look like this, that basically the position plus the move vector, so adding these two vectors together gives us a new position vector like so. And what's actually happening at a mathematical level is that we're simply, to get the new positions x, we are adding together the x position of the original position plus the x of the move, and the same thing with the y. So let's take a little bit more of a look at addition and subtraction with vectors. Essentially what we're saying is if we had a vector A that looks like this and a vector B that looks like this, then adding them together would give us the vector. Suppose we say that adding them together gives us a vector C, then vector C is simply the arrow that goes straight to the destination. Essentially, you put these vectors head to tail, like so. It doesn't matter which order you do it in, by the way. You could put B first or A first. You're going to end up with the same location here, vector C, which just points straight to the final destination. It's like it's taking a shortcut. And subtraction is incredibly similar. If you got vector A and vector B like this, then subtraction just involves taking a negative vector B, which is a vector that points in the opposite direction to the normal vector B, and then you can just go ahead and add them together as you would, which is going to end up looking a little bit like this, where vector C points to this location instead. Let's have a look at vector multiplication now, specifically multiplying a vector by a float. What happens if we take A and we say we want to multiply A by 2 to give us vector B? Well, in this case, it's actually fairly straightforward, because all you've got to do is think about adding together two vector A's. That gives you a vector B that is twice as long. The size is twice the size of a vector A. And in fact, you don't have to be restricted to whole numbers here. You could have half of a vector A is just going to be half as long. You could have 5.6 of a vector A, which is going to be 5.6 times the length of that vector A, but the direction ultimately doesn't get changed. It will always have the same vector direction. So let me challenge you to a little treasure hunt here. I've defined an A, B, and C vector. I've given you their visual representation with the arrow that is a size and a direction. I've also given you their numerical representations down below. And what I would like you to do is, assuming we have our character here on our XY axis grid, and we get given the cryptic treasure hunt directions given here. We've got A plus 3 times B minus C. That's where you will find the treasure. See if you can figure out where this character's got to move to find the treasure. Pause the video and have a go. Okay, welcome back. So first of all, A, we add A to it. We don't have to do any multiplication of it. So we can add A and it's going to take us to this location over here. Then we are going to add B, but we're going to add it 3 times because it's multiplied by 3. And then we're going to subtract C. So we're going to go in the negative directional C, or you can see I'm putting the arrow the other way round. So head to head instead of head to tail. And that effectively is the same thing as going in the opposite direction. And you can see we've ended up at this location here, which actually the resultant vector is this one here. That's the result of adding all those vectors together. So it's new, but its new position, its actual coordinate, because we weren't at 0, 0 when we started, the actual coordinate is 5, 1, x 5 and 1 on the y-axis. And the total resultant move vector is 10, 3. And you could verify this for yourself by actually adding together and multiplying appropriately the x's and the y's separately, and you just end up getting this movement vector defined here, which is that blue one showing up on the grid. So hopefully that's given you a little bit of a primer on adding vectors, subtracting them, and multiplying them. In the next lecture, we will put this to use. I'll see you there.